All right, all right. Everybody, welcome. Good afternoon from wherever you're watching me. Welcome to your study parts, a place of excellence where we give you the very best in terms of dealing with what problems with regards to what academic challenges from various subjects, ranging from your mathematics, English, which remains the core foundation for other subjects, as well as other subjects in the sciences, commercials, and art. Today, being your favorite subject teacher, handling the subject physics, we'll be pushing forward in our quest to conquer the realms of what? Physics, digesting and breaking down every bit of questions which we have. You want to mute yourself, somebody?
Maxwell, please mute yourself.
Okay, so we want to try as much as possible to build up that confidence we need in terms of facing our UTME examination this year. Remember, the focus has not changed. We are fighting to achieve a 200 plus as a testimonial from our JAMB examination. And I tell you, it is possible. Let physics not be that challenge. You want that challenging subject. Because I know for some of you, you will tell me, medical students will be like, oh, I'm good to go with my English. I'm good to go with my biology. Just my chemistry and physics. And among the two, I'm not so sure of my physics. Yes, it's usually happen like that. It's because you've not built your confidence base. But that's why I'm here. And that's why your study part is here. Ensure to follow us, like and subscribe on our platforms, on our YouTube channel, on our TikTok, on our Instagram channels. Endeavor to subscribe. Trust me, you won't regret any bit of the time you're spending on our platforms. So let's get right into the business of today. Physics remains the subject, and we're looking at an interesting aspect, talking about electric field in relation to static electricity. We're looking at electric field in relation to static electricity. One boring part in physics you want to say? Well, it's not actually boring. It's because the loss of interest in this aspect of physics is simply subjected to the fact that it is not practical enough, meaning that what? You don't have examples to cite around. Take, for example, when we were treating the topic refraction of wave, it was easy for us to tell ourselves that whenever waves are being refracted, you always have them move from one medium to another medium. And we could cite the example of having water placed inside a glass cup, such that you have water inside your glass cup and a spoon inside it. Looking from the side of the glass cup, it tends to appear as if the spoon is bent from the usual position. This is the resultant effect of what? Refraction. So, there are examples to cite and practical instances to use as illustration talking about this aspect of physics. But when we come into our realm of electric field and static electricity, there are less of examples to actually cite. It's more of an abstract part of physics. That's why students lose interest. But don't worry, we try our best here in your study parts to bring it to your doorstep, just the way you need it. So, electric field. Look at it as this. Some of you are already familiar with the football field. Now, when we have the soccer field, people playing football, you know we always describe your football field as a region where football is being what? Played. Now, you can relate with me. Whenever we say that what? The ball goes out of the field, there has to be what? A sequence that needs to be initiated for that ball to come back to that field. It's either through throwing. Please, my sisters in the house, I know you are not football fans like that, but bear with me using this example. It's either we have that what? Throwing takes place whereby the ball is being called in, or we have what? Goal kick being initiated, or we have a corner kick being what? Initiated. Why? That region is being influenced by the ball. The region where that ball is being played is what we describe as football field. Take it into what? Our knowledge bank now. Whenever you are describing electric field, we are talking about what? A region in which what? Electric charge effects can be what? Experienced. Electric force can be experienced. What is an electric field? We are simply describing a region around which what? Electric force can be what? Experienced. Remember, we have also talked about magnetic field. We said magnetic field is a region around a magnet where magnetic force can be experienced. That is why it is true to say today that when we have a bar magnet and you place your bar magnet down, you tend to discover that what? It is not necessitated that what? Your nail has to touch your bar magnet before attraction takes place. I'm sure you can relate to that. It is just a question of what? The nail coming close to the bar magnet. It just has to come close to it. And you see what? A force attracting the nail, or you have what? A repulsion occurring, when in the case of what? Two magnets. So, the region around that magnet where the force can be experienced is where we are describing as what? Being your magnetic force in the case of magnets. So we are using one stone to kill as many birds as possible. Remember, we have it for gravitational field, talking about the region around the Earth where gravitational force can be experienced when you are dealing with what? Gravitational field. When we are dealing with magnetic field, we say it is a region around the magnet where magnetic field can be experienced. When we are talking about electric field, we simply say it is a region around what? A charge. Now that is the word. It's a region around a charge. Whenever we are talking about electricity, we are making reference to charges now. So it is a region around a charge where what? Where electric what? Force can be experienced. Now, I'm going to give you some step-by-step explanation for you to actually remember the formulas attached to these lines. They are formulas you have to put in mind, because here under static electricity, we help to understand that there are actually two types of charges which we'll be talking about: positive charges and negative charges. Positive charges, negative charges. We tend to describe what happens to charges in the scope of this topic. Now, one of the key things you want to learn and understand is the fact that whenever you are studying charges, it's expected of you to note that what? There are ways to initiate positive charge, there are ways to initiate negative charge. For example, JAMB will always play around questions like this. Whenever we have an ebonite rod being rubbed on 4, I know I'm speaking grammar to some people. Why? They are not familiar with those words. Check it out. Ebonite rod plus 4. There is a charge expected of you in this case. And that's what? A negative charge being initiated. You talk, for example, with regards to making reference to plastic on 4 or rubber. The usual common one would be rubber. Rubber or plastic. On 4, you are making reference to a negative charge being initiated. That's what your UTME exam is going to be centered on, talking about this instance. What about if you're having this guy? Your glass on silk. Then you're making reference to what? A positive charge. There are other illustrations. Take, for example, when you're making reference to having that thing we did back in primary school, secondary school, where we had our biros. You have your pen, you rub it on your dry hair, and you cut a piece of paper. You bring the biro close to what? Close to the paper, and you tend to see what? Attraction taking place. It is simply because you are charging your what? The biro, the pen you have in your hands, rubbing it on your hair. You are trying to create a charge around it. As such, bringing it close to that paper, you tend to create an attraction. So, you won't have all these illustrations being used in physics. They are structured examples they'll always mention in your physics exam. What are they? Ebonite rod, rubber, glass. They are rubbing these materials on which materials? 4 or silk. These are always the materials they use in your UTME examination. So how do you want to remember? Positive. Which alphabet is present here? Alphabet S. Check it out. We have the what? Glass, alphabet S ending it. Silk, alphabet S ending it. So, you want to tell me today that you have a way of remembering what charge is going to be produced when you are rubbing glass on silk. The ones that carry alphabet S, I'm only trying to give you a shortcut for you to what? Acclimatize yourself with the charges. It's not having to just cram your work. Note that what? Glass has an alphabet S. So when you see JAMB writing the words, you want to just check, oh, this man made reference to the fact that what? Anytime I have glass, I can easily remember it because glass is combined with another material having alphabet S, silk. And they produce a charge that has alphabet S in it, positive. I've given you a shortcut. I've told you the length and breadth of the materials they can always what? Bring out. They can always what? Bring out. So these are the 4 materials or 5 materials they use. Ebonite rod, rubber, glass, silk, and 4. Always, they don't change it. That's why I say it's easy to pass your UTME examination. It's simply because you don't know how to read at times. That's why that fear is always there. Trust me, you can get the best. This is what UTME is asking you. Negative charge. You have your 4. You have your what? Rubber. 4 rubber. Negative charge. 4 and rubber. Ebonite rod. Alphabet R is being emphasized here to give what? Negative charge. The R part is producing negative. The S part is producing positive. Have that at the back of your mind. That being said, then you are good to go to launch into other aspects. Then what are the other aspects you want to? I'm trying to create a summary. Don't worry, we'll still have the note part and the explanation behind it. So don't be scared. Now, we want to create a family tree. That's another way to remember. A family tree in terms of how the formulas are actually connected. So we'll talk about electric force. You see this man, electric force, is the grandfather of all the formulas you want to put in your head. Alphabet F. Electric force actually gave birth to a son. And that son is what we are describing as electric field. Wakey wakey, time to learn things. Now, alphabet E is what you need to know as the son of what? Electric force. Why? These formulas, these are the 2 formulas that are always related. Anytime UTME examination comes, they are asking you a question. They are linking force with what? Electric field almost every time. When you note that, then you can relate it to this guy. Electric potential. This is the grandson coming from what? Electric force. An electric potential has a cousin called what? Potential energy. So this is how the family tree goes. We said that energy can neither be created nor destroyed. You can transfer it from one form to another. And we said energy is the ability to do work. As such, potential energy and work done by a charge, they relate them together. Stop stressing your life. Only these 4 things are the formulas that JAMB keep repeating. And you keep failing it. Only 4 formulas. Just 4 formulas. And you keep what? Mixing them up. I call them, this guy is alphabet V. I call them FEV-P. FEV-P. The 4 formulas, FEV-P. That's how we relate them. The formulas are aligned under this progression. So check it out. You don't want to be scared. For this first guy, what is the formula you have under force? You have that electric force is attributed to K Q1 Q2 over R square. It is similar to what you have under gravitational force. Go and check your notes. We've done something on gravitational force before. Go check your notes. You will see that under gravitational force, we are dealing with Gm1 M2 over R square. It is similar. Only that in this case, we are relating charges involved. The R still remains the distance between the charges. Having that being said, Your electric field shares a formula, but not as complete. It's just like imagine a native doctor, for example, having his trade, is actually teaching an apprentice. The reality remains that we always say that what the native doctor will never release everything about his trade to the apprentice. Why? He knows that if the apprentice knows everything, there's tendency that what that apprentice might use it more for negative things. As such, it is always what? Avoided. So, on the basis of this, sorry about that. On the basis of this here now, we have that what? Electric field learns work from electric force, but it did not learn complete work. That is why for electric field, there's an aberration to the formula. See, something is cut off. See, instead of having Q1, Q2, we have only what? 1Q. Remember we said that what? Electric potential length work from electric field. As such, instead of electric potential to learn the full work from electric field, it never did. As such, instead of having KQ over R square, electric potential V now became KQ over ordinary R. So what is scaring you about this topic that makes you see anything under electricity, static electricity, and you're like, no, this part is too difficult? Stop deceiving yourself. It's very easy. So check it out. We have the formula. We have the formula. Under potential energy or work done, it is here we now said that what? Work done is equal to QV. Charge times voltage. Charge times voltage. That is why this V value here now embraces 1Q here. And that is why you are seeing Q multiplied by KQ over R. And you are having KQ square over R. That is the only alteration for your potential energy or work done. They share the same formula. So look at it. Electric force. KQ square over R square. KQ1, Q2 over R square. Your electric field lost one of the charge values. So you are just having KQ over R square. Your electric potential lost one R square. Instead of the R square, it's lost one R. KQ over R. And the last but not the least, instead of this guy losing now, the potential energy or work done, losing, it's actually gained one charge extra. And that's why we are having KQ square over R, or you'll be having KQ1, Q2 over R. So you can either say it like this, KQ1, Q2 over ordinary R. These are the only four formulas. Check through all your what? All your past questions. So in the light of this, can we get down to writing notes? Because I know some people, if all this grammar I'm blowing now, there's no notes to read later, it becomes a problem. It's no worries. Let's take down some things. So starting with, we said that what? Electric field. So we are picking electric field first. Electric field is a region around a charge where electric force can be experienced. Electric field is a region around the charge where what? Electric force can be experienced. Now, I like you as a brother. I like you as a friend. I like you as an uncle. I like you as a teacher. As such, it is for me to call your attention to something some of you are not familiar with. And what is that? It is for you to know that you shouldn't be expecting them to always mention electric field every now and then inside your past question. That is another selling point for your UTME examination. They will always not mention what? Electric field every now and then. They will always twist the names. And there are about 4 names you should know what we call electric field. Other names we call what? Electric field. So here is it. Electric field can also be called what other name? Number one, we can call it electric field strength. So when you are solving your past question and you see electric field strength, know that they are still talking about the same guy, electric field. Once you are seeing electric field strength, know that they are still describing electric field. Whenever you see the word electric flux density, electric flux density, know that they are still talking about electric field. And when you see electric intensity, electric field intensity, you know they are talking about what? Electric field. So these are the other names. So when you don't see electric field, you can see electric flux density. They are still talking about the same guy. And how is this possible? You can have one person different, representing what? Different personalities or playing different role. One personality playing different role. That woman that gave birth to you, you address her as what? Your mother. The person that married that woman that you are calling your mother, we always address her as what? My wife. Isn't it? To somebody that gave birth to her, she's been addressed as my daughter. That is what you are having. Electric field can also be called electric field strength. Electric field can also be called electric flux density. Electric field can also be called electric field intensity. So having said that, what is the unit of electric field? You should know that. The unit of electric field. Electric field is measured in Newton per Coulomb. Newton per Coulomb, meaning N/C. Newton per Coulomb, force divided by charge. Newton per Coulomb. And this is because it is denoted by alphabet capital E. It is denoted by alphabet capital E. So, bringing it to you, we can say that what? Mathematically, E is equal to force over charge. Force over charge. The alphabet for force is F. The alphabet for charge is this. And imagine a simple question as this, whereby they give you, they say calculate the force. It's just for you to cross multiply. Electric field times charge, and you get the force you are looking for. This is where we got our unit from. Force is Newton, charge is Coulomb. Newton per Coulomb. Having said this, before we dive forward into this part whereby we're having